Good day, Doctor. We are from Group P3W2 and our article topic is Evaluation of Ergonomic Conditions Using Fuzzy Logic in a Metal Processing Plant. I'm Vanessa and my teammates are YULUN, DENG and FIRDAUS. The study was conducted in a metal processing plant in Turkey to solve the problem of prioritizing departments which need ergonomic improvements. The two key values are illumination and noise levels, and there are 3 departments involved in this study. The author highlighted why fuzzy logic was chosen, as traditional methods give binary results which are not relevant to real-world conditions. Fuzzy logic, on the other hand, handles uncertainty and uses linguistic variables, which allows human-like reasoning in decision-making.
Let's look at how we gather our data. We focus on 2 critical factors, illumination and noise. For illumination, we use the exact SDL400 light methods. Our safety benchmark here is 700 lux. Anything below that risks precision and safety. For noise, we use SL355 version no DOMIS methods. The regularly red flag is between 80 and 87 described. 80 requires protection and anything over 87 is the strict exposure limit. We look these tools to 3 different departments. As you can see in the table, the results are mixed. Laser 1 is bright enough at 857 lux, but the noise is dangerous at 91.1 dB. Welding 1 barely passes for light, but it has the worst noisy pollution of all, sitting at 94.3 dB. Welding 3 is the most problematic. It fails both tests. Lighting is poor at only 575 lux and noise is high at 88.4 dB. This creates a dilemma. Some areas have bad light, others have bad noise. It is hard to rank them just by looking at the raw numbers. To solve this conflict, we apply the Mendelian fuzzy inference system. Real life isn't black and white, so a simple pass or file check isn't enough. We need to measure degree of risk. We convert our raw data into linguistic terms like bad, average, and good. The graph on the right shows our membership function. We use a triangular shape to map the extra number into fuzzy value. This helps us calculate the degree of the problem rather than just saying yes or no. And here is how we process that data. We build 3x3 raw measures in the MetaLab fuzzy logic toolbox. This measures cross all 9 possible combinations of lighting and noisy condition. The system tests our inputs and use the centroid methods to defuzzify them. Simply, but it turns those complex fuzzy risks into a single, clear priority score. This score tells management exactly which department needs to be fixed first.
Moving on to key findings, as you can see in the table, the evaluation scores for each department. For the conclusion, welding 3 is our first priority because it has the lowest evaluation scores. For welding 1, our second priority, and laser 1 is our third priority. Next, for practical application, welding departments, both welding 1 and welding 3, have dangerously high noise level and poor illumination. We need to start improvement in welding 3, our first priority, and then welding 1. So last, for the logic, provided a quantitative ranking from subjective measurement. Next, for strength, we can handle uncertainty in ergonomic assessment. We can combine multiple factors into single decision metric, and it is easy to understand for non-technical managers. For limitation, we only got 2 factors considered, and it is limited to 3 departments and also required expert judgment for membership function. Last but not least, this study demonstrates how fuzzy logic transforms complex ergonomic data into an actionable priorities that can help companies protect worker health while improving productivity. The methodology can be scaled to any industrial setting regardless of the field. That's all. Thank you.